Thank you. So I'm excited to be here today. I'm presenting tips and tricks for Next.js and Sitecore Headless. So the idea of this talk is I'm going to present about 10 tips that I hope that you can go and apply to your projects right away after this. So I'm Corey Smith. I'm an independent consultant living in Atlanta, Georgia in the United States. I'm an 8-time Sitecore MVP of technology. I've got over 9 years of Sitecore experience. I'm a happy dad to an almost 2-year-old, and I'm big into lawn care and smooth jazz. So if you like either of those things, I invite you to reach out to me on Slack at Sitecore. That's my handle. Happy to chat about those things or any of the tips and tricks I talk about today. And you can check out my website at corysmith.co. Every Friday at 12:15 p.m. Eastern Time, I co-host Sitecore Lunch with my good friend and fellow Sitecore MVP, Jim Patillo. If you've not heard of it before, Sitecore Lunch is a virtual meetup that's hosted on Zoom, and it's an opportunity for members of the community to just unwind on Friday and chat about Sitecore or any other topic that pops up. We don't have a set agenda. We often have Sitecore employees join us and they'll talk about the products or answer any questions we have. So it's a really good time. If you're interested in joining us, the details to join are here on the screen. Every single Friday, 52 weeks a year at 12:15 p.m. Eastern Time, I post the details to join the Sitecore Lunch in the Sitecore Slack general channel. And if you're not on the Sitecore Slack, please join us. You can join at that URL, sitecore.chat. I hope to see you all later today. So our first tip today is looking at the debug logging functionality in Sitecore's Next.js SDK. Sitecore's Next.js SDK ships with pretty extensive debug logging functionality provided by an NPM package called debug. When enabled, it will output lots of handy debug information to the console and to the browser for things like layout service requests and dictionary service requests, as you can see in the screenshot here. And this is really nice for debugging issues that you may have with your site. This functionality, it's hiding in plain sight in every Next.js project. To enable it, what you'll do is you'll just go and look in the .env file for your Next.js application and look for this block of comments. And then all you have to do is just uncomment this line right here to enable debug logging. This line will enable all debug logs. So Sitecore-JSS star, that turns on all the debug logs that Sitecore makes available. But you can get more granular. So if you want to see just logs for the layout service, for example, you can uncomment this line in the .env file, and you'll only see the layout service logs. You can get even more granular than that. If you uncomment this line here, what this will show you is everything but the layout service logs. So we've got Sitecore JSS star and then minus Sitecore JSS layout. This will show us everything but layout service logs. So you can get as granular as you like to really hone in on exactly what you need to debug. One thing that you will not see in the .env file is this setting, debug multiline. And I highly recommend that you turn this on because it makes the debug logs a lot more readable. So when you turn on debug logging by default without debug multiline set to true, this is what the debug logs will look like in the server console. But if you set debug multiline to true, then the logs will look like this. And I think this is a lot more easy to read. So I make sure that I always turn that on anytime I'm using debug logging. So here's a list of all of the debug filters that the JSS team makes available in the Next.js SDK. So of course, there's the filter for all debuggers, the Sitecore JSS star. If you want to look at the debug logs for the data fetchers, you can turn that on, layout service, dictionary service. If you're having an issue with editing and pages or in the experience editor, you can turn on the debug logs just for the editing host. If you're using Headless SXA, there are some debug logs for the SXA features like the sitemap service, the site info service, error pages service. And then if you're using CDP or personalize, there's debug logs for those as well. So we just looked at debug logs in the server console. To turn on debug logging in the browser, it's slightly different. The settings that you put in the .env file don't affect the browser. So to turn on debug logs in the browser, what you do is you just open up your browser console and you set the debug property on local storage to the filter that you want to see. So this would turn on all the debug logs in the browser. And once you do that, anytime those debug logs get triggered, you'll see them get output to the browser console like this. Now, I want to point out the fact that when you start a new Sitecore JSS Next.js project, almost all of the debug log functionality is going to get triggered on the server console. There's really not going to be anything that you'll see pop up in the browser. But this can still be useful, and we'll come back to this in a later tip, and I'll show you instances where this will actually get triggered. But if you turn on debug logging in the browser for a new Sitecore JSS project, don't be surprised if you don't see anything here. So to recap, you can enable debug logging for the server console in your .env file. Make sure you always set debug multiline equals true for better readability. If you want to turn on debug logging in the browser, you just set that debug property on local storage in the browser console to whatever filter you want to see. And then you can actually make your own debug namespaces if you want. So if you want to make your own application specific namespaces, you can use that debug package to do that on your own. And there's some really good documentation on the npm.js site about how you can create your own namespaces. So I highly recommend checking that out. And then Sitecore has got really good documentation on the debug logging as well, again, covering all those filters that I pointed out and so forth. So this tip is going to look at the data fetchers provided by the JSS libraries. The Sitecore JSS library exports 3 fetchers that you can use in your application. There's the native data fetcher, which uses fetch under the hood, the Axios data fetcher, which uses Axios under the hood, and then there's the GraphQL request client, which is configured to make calls to the Sitecore GraphQL APIs. It has really nice retry logic and handles rate limiting against Edge and things like that. So if you're making GraphQL calls against Sitecore, you want to use the GraphQL request client. For general API calls, if you like Axios, you can use the Axios data fetcher. But probably for 99% of people, the native data fetcher is what you want to use. And the reason for that is it will benefit from any features added to Fetch by the Next.js team. So Fetch, the Next.js team actually ships their own implementation of Fetch, and they've added some new features to it over time for the app router, like request deduplication and caching. And if you use the native data fetcher, you'll get those features for free as you upgrade Next. But if you use the Axios data fetcher, you're not going to get those. So I recommend either use the GraphQL request client or use the native data fetcher for any of your data fetching needs. But the real advantage to using all of these is that they're configured to use debug logging under the hood. So anytime you use one of these data fetchers to make an API call, you can add the Sitecore JSS HTTP filter to your env file or into the browser console, and you'll see logs for them. They're pretty easy to use. So if you want to use the native data fetcher, you just import it from the JSS libraries like this, and then new up a new instance. And the interface is almost identical to using Fetch directly, so quite easy to use. As I said before, these all implement debug logging under the hood. So when you're using these data fetchers, if you just set debug to the Sitecore JSS HTTP filter, and of course, turn on debug multiline, then in your server console, anytime those data fetchers are used for server-side API requests, you'll see the request come through in your server console and also the response like this. If you use one of these data fetchers in some client-side functionality, like inside of a use effect hook, for example, when you set the debug property on local storage to the HTTP filter, then you'll start seeing debug logs for those data fetchers in the browser console like this. So to recap, Use the native data fetcher instead of fetch. If you like Axios, you can use the Axios data fetcher instead of Axios. Always use the GraphQL request client to call the Sitecore GraphQL APIs. And the big benefit to using these is that you get the debug logging for free. For this tip, we're going to look at the component level data fetching feature in the Next.js SDK. Let's start by looking at a typical data fetching scenario. This is a really simple React component that's using the useState and useEffect pattern to make an API call. This is just the standard data fetching pattern you'll use in React components. You first declare some state using useState, and then you make your API call within a useEffect hook. Inside of the useEffect hook, when you get your API data back, you update the state with whatever your response is from the API, and then this will trigger a re-render of your component. So while you're waiting for that API call to execute, you might show a loader while your state is null. And then once the data comes back and your component re-renders, you might render the data from the API call. Big problem with this pattern is the useEffect hook, because the useEffect hook, it only executes during client-side rendering. It doesn't execute during server-side rendering or static site generation. So any components that are using that pattern, they're going to have a loader and they're going to have a flash when the API call loads in the browser. So on initial load of the page, you're going to see a loader. And then when the component re-renders, it'll refresh and it'll show the data from the API. The problem is this isn't the best user experience, and it can also have negative impacts for SEO on your site. But the cool thing is Next.js actually has a solution for this at the page level. And that comes in the form of two special functions called getStaticProps and getServerSideProps. These are server-side data fetching methods that you can use to do data fetching during server-side rendering. So if your application is using SSG or static site generation, you use getStaticProps. If your application is used server-side rendering or SSR, then you use getServerSideProps. Let's look at a simple example. So again, this is just talking about a vanilla Next.js app. We're taking Sitecore out of the picture here. In a vanilla Next.js application, getStaticProps and getServerSideProps are page level functions. So you export one of these functions from your page like I've done here. So I've got my page, and then alongside it, I'm exporting getStaticProps. Within this method, you can make your API call. Then when your API call gets its data back, you just return that data from your getStaticProps or getServerSideProps method. And during server-side rendering, Next.js will magically pass this as a prop to your page. And then from your page, you can start passing that prop down, that data down to your components that the page is going to render. So this is a really nice feature, gives us a way that we can avoid the content flash and improve SEO and make API calls without useEffect. However, since these methods must be declared at the page level, you have to do data fetching for all of the components that are going to render on your page at the page. In a vanilla Next.js application where your pages are generally static and you know all the components that will be rendered ahead of time, maybe that's okay. But in Sitecore, pages aren't static, right? We're not going to have all of our components listed on the page like this. Instead of all these components being listed on a page in a Sitecore application, we'll just have a placeholder, and content authors are the ones selecting the components that will be rendered, and they'll be dynamically injected at runtime. So doing data fetching for all the possible components in your component library for every request would be a really big waste, especially if only a small handful of those components are going to get used on a particular page. So the Sitecore JSS team has implemented a really cool feature to address this problem, and that's the ability to not only declare these functions at the page level, but to also declare them at the component level. So let's go back and look at our data fetching example from before. So we've got our simple component here that's using that standard data fetching pattern of useState and useEffect. And we can refactor this very easily to use one of these component level data fetching functions. it would look like this. So now our component, alongside our component, we can export get server side props or get static props. And inside of that server side data fetching function, we make our API call and then return our API data back from the function. The Sitecore JSS Next.js SDK is going to magically take this and it will pass that data down to the component that needs it, and then you can render it, and you don't need a loader. All that data will render server side, which is really nice. The other thing that's really nice about this is your get static props and get server side props methods are going to be very close to the components that need that data fetching, right? So if you put all this stuff at the page level, those methods and that business logic is going to be pretty far away from the components that need it, but this allows us to keep our code nice and clean and all the related code together. So if we go back to our screenshot, there's no animation to show here because now that API data, it's coming from the server and it's going to load in the initial HTML that's provided up to the browser. So there won't be any re-renders of your components or shifting or anything like that. So it's quite nice. So this is all great, but there's one thing to be aware of. If you are using a version of JSS before 21.6.4, pay very close attention to what I'm about to say. There's a major bug in versions of JSS before 21.6.4. Page level get static props and get server side props are excluded from the code that's sent up to the browser. And this makes sense. These functions are only going to get executed during server-side rendering, so there's no point in sending them to the browser. Vercel in their documentation even tells you that since this code is only going to live on your server, you can have things like connection strings and API secrets that are consumed in this code for doing data fetching. And that's perfectly safe, and in fact, it's encouraged. However, component level get static props and get server side props are not excluded from the client bundle for versions of JSS before 21.6.4. This is a bug in the JSS Next.js SDK. So if you're using a version of JSS before 21.6.4, you must take very special care that you do not include any kind of sensitive data in those component level get static props or get server side props methods. So if you put a connection string in those component level functions, or if you put an API secret, those will actually get sent up to the browser in plain text, and any clever user that browses your site will be able to get access to those connection strings, the API secrets, passwords, whatever. So if you're using these component level functions in an application that's on an older version than 21.6.4, I suggest you go and do an audit of your application. If you see any secrets or connection strings being used in those methods, go ahead and consider them compromised and replace them as soon as possible. Get them out of those methods and upgrade JSS if you can. With that being said, even with this bug, if you're stuck on one of those older versions, I still think there's a lot of value in using these component level server data fetching functions. You just need to be aware of that limitation. So to recap, you can use with a JSS application, you can use get static props and get server side props in your components. If you're on an older version of JSS, upgrade to 21.6.4 or higher as soon as you can. And if you can't upgrade, just take very special care that you never put sensitive data in the component level get static props or get server side props functions. Some further reading, if you want to go and see the changes that they made in 21.6.4, there's a link to that. I opened up an issue on GitHub last year when I discovered this with Sitecore, and if you want to go and track that and see that conversation, there's the URL. Sitecore's got really good documentation on this feature that you can check out, and then Vercel's got good documentation on the page level functionality that I highly encourage you read as well. Okay, so we just spent a good amount of time talking about data fetching on the server side. So let's switch back up to the client and look at a library that will help you really improve your data fetching in the browser. So going back to our example from before, the standard API call pattern in React components is pretty kludgy, right? You have to use two different hooks. You use state, and then you make your API call inside of a use effect hook. Inside of that use effect hook, you update state to trigger a re-render when your API data comes back. And then you might show a loader when your state is null or undefined. And then once the API data comes back, you'll re-render your component. This works fine. Again, this is the standard React component or React pattern for doing data fetching on the client, but there's a much better, cleaner way to do this. And that comes in the form of a data fetching library called SWR, which stands for Stale While Revalidate. This library is developed and maintained by Vercel, the company that builds Next.js. So let's look at an example. SWR is just a really simple React hook that simplifies data fetching. So now instead of having to use state and use effect, you just use the one use SWR hook like this to make your client-side API calls. The first thing that you'll pass to SWR is a key or a URL that you want to do your data fetching against. So in this case, we're just giving it the URL to the catfact API. And then the second thing that you'll pass to SWR is a generic fetcher function. And this just tells SWR how you want the data to get retrieved because it doesn't actually do data fetching itself. So in this case, we're just using fetch. SWR is then going to return a whole bunch of really handy data to you. It'll return a Boolean that tells you whether or not the API call is loading. If an error happens, it'll return an error object. And finally, it'll return the data from your API. There's a lot of other stuff it'll return as well, but these are really the things that you're going to be focused on when you're getting started with it. And then the really cool thing is instead of doing something kludgy like looking at state and using whether the state is null or not to show a loader, you can be a little bit more declarative and actually be confident that you're showing your loader when the API call is loading off that is loading Boolean, and then just otherwise show your data as normal. So this is a lot cleaner code than using use effect and use state, but clean code is not the only reason to use SWR. It actually comes with a bunch of features out of the box. This is not an exhaustive list, but these are some of the more eye-catching features. Two that we're going to look at in a second are auto refetching and request deduplication. These are two things that you'll get for free when you use SWR. You don't even have to do any setup. SWR does prefetching of API calls and caching. It's really good at handling pagination and infinite scroll, and it's got native support for TypeScript. So let's look at two of those features. So the first feature we're going to look at is auto refetching. So when the browser loses and regains focus, SWR will automatically refetch all data for you. So this ensures that your users always have the latest and greatest data from your APIs. So you can see when I click in and out of the browser here that I'm getting a new cat fact for all the components. And don't even have to do anything. You just start using the hook and you get that feature automatically. The second feature is a little bit more subtle, and that's request deduplication. So if this catfact component used the use state use effect pattern, on this page, you would see a different catfact for every single instance of that component. However, SWR is smart enough to see that the same API call is getting made by multiple components on the page. So what it'll do is it'll actually just make that API call once for all the components, and then it'll share the response to all of them. And this will improve performance and it's just a really nice feature. So that's why you see the exact same catfact showing for all of the components here. Again, both of these features you get for free as soon as you start using that hook. You don't even have to do any setup. I showed previously with SWR that you supply a generic fetcher function. If you want, you can even use the JSS data fetchers. So here, what I'm doing is I'm just setting up a fetcher function using the native data fetcher and providing that to SWR. Cool thing about this is now that SWR is using the native data fetcher to make API calls, when you turn on the debug logging in the browser, you'll start getting debug logging with SWR. So that's quite nice. There's also a really handy browser extension called SWR DevTools that you can get. Add this to your browser and you'll get an SWR tab that you can use for debugging SWR. So you can do things like look at the SWR cache, look at the history, look at the network calls that it's making. So to recap, SWR simplifies your data fetching code and in fact supercharges it with a whole bunch of handy features. But SWR is not the only game in town. There's another really nice library called React Query that's a great alternative to SWR. And if you've not used SWR or React Query, I highly recommend that you check out both of those before settling on one. I've used both with great success in projects. So for some further reading, you can check out SWR on Vercel's website. If you want to get the SWR DevTools and install that in your browser, there's the URL. And if you're interested in React Query, there's the URL to React Query website. For this tip, we're going to look at mocking data for pages in the experience editor. And this tip is going to combine the previous two tips. Sitecore developers are really tasked with developing for two applications when we develop a website on Sitecore. We're going to develop the application that the end users see, of course, that they're going to browse to, but we're also developing an application for XM Cloud and Pages and the experience editor for our content authors to use to build pages. When developing pages for pages, or when developing your application for pages in the experience editor, it's important to keep in mind that these applications are really just for developing layouts. They're not for testing APIs. So in Pages and Experience Editor, rather than making live API calls, I strongly suggest that you serve up mock data for your components that rely on data from the APIs, and just in the Experience Editor and Pages, show some representative data to give the content authors an idea of what that component will look like, but don't actually make live API calls. And the reason for that is that client-side rendering, such as React re-renders, can break the experience editor in Pages. So let's take a look back at our cat fact example from before. So this is a pattern I've seen a lot that causes issues in experience editor and can do it in Pages as well. So while the API call is loading, show a loader. But then once the API call finishes, render the API data, but also render a whole bunch of other stuff, like render a field from Sitecore using one of the field helpers such as image, or rendering a placeholder. The problem with this code is this is conditional rendering of Sitecore data using the field helpers. Blocking loading of Sitecore field helpers and placeholders like this is an anti-pattern that will absolutely break the experience editor and cause issues in Pages as well. The kind of things that you'll see when you do that is inline editing won't work. The component won't render properly when it's added in the experience editor initially, or placeholders won't work. So placeholders in that kind of scenario might show a message like could not find the rendering in the HTML loaded from the server when you try to insert something into that placeholder. So I want to show you now a way that we can use SWR and component level data fetching to serve up mock data in Experience Editor and Pages to avoid these problems. So here's our simple component that renders a cat fact. What we're going to do is, instead of always calling this during the client, we're going to load some mock data that will get rendered for Experience Editor and Pages. And the way we do it would be rewriting the component like this. The first thing we do is export get static props or get server-side props alongside our component. Inside of that method, we'll check if we're in Pages or the Experience Editor. And if we're not in Pages or the Experience Editor, don't do anything, because we don't want to change the behavior outside of Pages in the Experience Editor. But if we are in Pages or the Experience Editor, then return some mock data for our API call. That mock data could be hard-coded here, it could come from a JSON file, wherever. Then, when we return this data, it's going to come as a prop into our component, And what we'll do is we'll pass this to fallback data on SWR. What fallback data does is it just tells SWR while the API call is loading, return the fallback data as a placeholder. So now we've got a way to take our mock data and inject that into SWR for our API calls. The only problem is that we've still got an issue where the API call is going to get called in the experience editor and pages, and we don't want that because that's going to cause conditional rendering and create problems. So it's actually quite easy to turn off API calls for SWR globally when we're in experience editor in the pages. The way you do that is you would go to your topmost component, could be your Sitecore page, for example, and in that topmost component, add an SWR config element like this. Inside of that element, you set revalidate to revalidate focus on mount and revalidate on mount. You set both of those to false when you're in pages or the experience editor. And what this does is this tells SWR when we're in pages or the experience editor, don't make API calls. If there's fallback data, just use that and be done. And so this will avoid conditional rendering in the experience editor and pages and gives us a really clean way to provide mock data for those editing experiences. So to recap, don't call APIs in pages or the experience editor or do any kind of client-side rendering or conditional rendering. Client-side rendering of JSS field helpers and placeholders will definitely break the editing experiences. So instead, I recommend that you return API mock data for editing in the components get server-side props or get static props methods. You can then take that mock data and pass it to SWR's fallback data capability. And then just make sure that you disable revalidate on mount and revalidate on focus when you're in one of those editing experiences to prevent API calls from being made. And I mentioned React Query in the previous tip. This is also possible with React Query as well if you're interested in it. Just don't have time to cover both of those today. Okay, the last 4 tips were quite extensive, so we'll take a break and look at a pretty easy one. This is another one that can cause issues in the experience editor pages, and that's always define a root element. This tip actually doesn't just apply to Next.js. It applies to all development models in Sitecore, XSLT, web forms, MVC, Angular, Vue, pure React, Next.js, it doesn't matter. This is a hard requirement for experience editor and pages. You must wrap your components in a single real root element. So I sometimes see components that are wrapped in a fragment like you see here. The problem is the fragment, this doesn't really exist in the HTML document. This doesn't get rendered. And if you do this, you'll cause all kinds of issues. Styles will get broken in experience editor and pages. Inline editing won't work properly when you first insert a component, or placeholders won't work properly. And the fix is quite simple. Just make sure that your components always have a real root element, like a div or a span like this, and your content authors will be so happy. This might be a good opportunity for a community plugin, like for ESLint or Prettier, that detects these things, because I'm sure that this is something that's easy to catch during static analysis. This next tip is pretty easy too. This is looking at disabling Next.js telemetry. So if privacy is a concern for you or your clients, just turn this off, because Vercel is collecting telemetry from your Next.js server and sending that back to themselves to do analysis of what features are getting used and to help improve the product. But if privacy is a concern, it's easy to turn this telemetry off. All you have to do is go into your .env file, set next telemetry disabled equals 1, check it into Git, and you're done. Sitecore's got some documentation on this that you can check out here. Vercel's also got some documentation. That's not the only way that you can disable the telemetry, but I think it's the easiest. Highly recommend that you check both of those out. For this step, we're going to look at a feature in the Sitecore Next.js SDK that will help you with upgrades of the SDK. And this is a feature called Next.js config plugins. So in the root of your Next.js application, there's a next.config.js file where you can configure all of Next.js's settings. In a new Sitecore Next.js application, there are already a bunch of things configured in this file. Some of the things that you can adjust with the next config are things like environment variables, default headers, image behavior. You can configure redirects and rewrites for the Next.js server. You can set Webpack settings. And all these things are nice to modify, and you definitely should if you have a use case. But modifying these things and changing these settings directly in the next config.js file can make upgrades of your front-end application a little bit more difficult. And there's a cleaner way. That comes in the form of config plugins. So this is a feature that is unique to Sitecore's Next.js SDK. In a Sitecore Next.js application, if you look in the lib next config plugins folder, you'll see a whole bunch of config plugins that Sitecore ships with. They're always going to take the form of this code that you see here on the screen. So if you use this pattern and create a plugin in this plugins folder, instead of modifying the Next.js config directly, you can create plugins that will change small pieces of the Next.js config. What'll happen is these plugins in this folder will get combined with the next config.js file by the Sitecore Next.js SDK at build time. So if you're coming from the .NET world, this is very similar to Sitecore config patches and web config transforms, right? On a .NET project, you never want to modify the web config directly. You always want to make those modifications either through a Sitecore config patch or a web config transform, and this is very similar. So let's take a look at a simple example. Say that you wanted to disable the X powered by header that Next.js includes in every page response. The easiest thing to do, of course, is to go modify the next config.js file and set powered by header to false. But instead of modifying that file directly, you can create a powered by header plugin in the plugins folder that I've shown here and just set that setting there. And again, at build time, this will get combined with the next config.js by the Sitecore SDK. And yeah, this will get applied just like normal. This is a very simple, contrived example, but you can imagine that plugins actually get complex quite quickly. Imagine you have a feature that requires on rewrites or redirect rules and several of them. It's quite nice to put those settings in a config plugin where you can name the config plugin after the feature that requires them, rather than just kind of going and putting them in random places in the next config file with comments. So I think this also lends itself to quite better, more modular, cleaner code. Just remember that anytime you create or change a plugin that you have to rebuild your application, hot module reload is not going to catch that. So to recap, don't edit next config.js directly. Instead, change your Next.js config settings with plugins created in this plugins folder here. And just always remember that anytime you create or change a plugin, you got to rebuild your app. This tip will help you get a better understanding of your website payloads. So this is looking at Next.js Bundle Analyzer. To get started, run npm install in your project like this and install the Next Bundle Analyzer. Then, going back to our previous tip on config plugins, you can create a config plugin like this to enable it. I recommend setting Next Bundle Analyzer to be enabled when the analyze environment variable is set to true like this. And also on Bundle Analyzer, set Open Analyzer to false. This Open Analyzer option is pretty annoying. It's going to open the Bundle Analyzer in your browser automatically after builds and will lead you to having thousands of tabs in no time. So just turn this off. So once you've got your plugin set up, then you can go and set analyze equals true in your environment variables. And then the next time you build your application, Bundle Analyzer is going to create some HTML files at these paths. It's going to create an HTML file for the client bundle that gets sent up to the browser. That's going to be the client.html. And then it's going to create an HTML file for the bundle that gets used by the server, node.js.html. When you open up those pages, this is what they're going to look like. This is an example of the client HTML page for a headless SXA site. So it's pretty cool. It's organized by all the different chunks for your application. You can see there's a chunk for main.js, there's one for the 404 page, one for the page route, and then one for the app. And you can see within the page route and the 404 routes, the includes from the node modules folder. You can see that they contribute quite a bit to the size of those files. And within each of those routes, you can see the source folder and all the renderings or the components that get included for those pages as well. The other cool thing is you can mouse over any block that you see here and it'll actually show you the physical size of each block and how much it's contributing to your page load. There's a sidebar that you can open, and from this sidebar you can filter what you see. For example, you can zoom in on a particular chunk. So if you want to zoom in on like the page route, you can do that, and this is what that looks like when it's zoomed in. Again, you can see that node modules is contributing the majority of the file size here. The Sitecore JSS libraries are contributing quite a bit as well. And then over here on the right are all the components or the renderings that are getting included for this page. The server-side bundle pages are going to look quite a bit different from the client bundle. For example, something you'll notice is that every chunk for the server has document.js included in it, but we didn't see that in the client bundles. And the reason for that is document.js is only executed on the server, so that doesn't get shipped up to the browser. To recap, you can use Next.js Bundle Analyzer to diagnose issues with your bundle sizes and find code, for example, that doesn't belong in the browser. Very easy to enable this with a config plugin. The documentation on the Next.js Bundle Analyzer can be found here. Our final tip is on a great package called Patch Package, and this is my favorite one. So Patch Package lets you patch files in the node modules folder and then share that patch with your team. These patches will get integrated into your repository and your code base, and they'll even make it into your production builds. So to get started with Patch Package, you just run npm install patch package on your repo or your app. And then in your app's package.json, you'll go and add a post install script for patch package like this. And this just tells npm, after npm install finishes, run patch package. The next thing you can do is just go open up your node modules folder and start modifying stuff. So if you want to make changes, for example, to the isEven package in node modules, you can just open up isEven's index.js and make a change. So here I've changed isEven to always return true on Mondays. Again, I'm doing this directly in the node modules folder. And you just save this change. And then if you want to share this with your teammates, what you'll do is go back to your terminal and run npx patch package and give it the name of the module that you modified. In this case, we modified isEven. Patch package is then going to go and download a clean copy of isEven or whatever module you modified and compare it to the module in your node modules folder and create a patch file. And it's going to put that patch file in your patches folder in your repo. It's also going to give you a command to go and open an issue with the package maintainer for that module. I recommend that you always do this. Anytime you create a patch using patch package, you need to let the package maintainers know about it because it's very likely that you're not the only one who needs this functionality merged in upstream for that package. So that's a handy command you can use to do that. All right, so the patch has been created. This is what the patch is going to look like in the patches folder. It just looks like a standard git diff. And you'll check this file into source control, share it with your team. And now anytime the npm install is run on your application, after npm install finishes, patch package will go look in your patches folder and will apply all of those patches to your node modules folder. Use this tool sparingly, however. This is a very powerful tool that can be easily abused. Again, if you find bugs in packages, you must report those to the maintainers. Don't just fix them for yourself. Let the maintainers know about that. But the reality is maintainers will often fix bugs in their packages, but for some reason you can't upgrade to that package version in your repo. Really good example. If you're on an old version of JSS before 21.6.4 and you want to fix that bug that I was talking about with the component level data fetching, patch package is a really great solution for that. You can backport that fix from 21.6.4 to an older version of JSS quite easily. So to recap, use patch package to modify node modules. Patches will get created in the patches folder of your repo that you can then check into Git and share with your teammates. Make sure that you're always submitting issues for patches to the package maintainers and use this tool sparingly. So here's some really good documentation on patch package that you can check out. And yeah, I think we've got a few minutes for questions. If anybody's got anything, happy to answer questions here, or if you want to reach out to me on Slack or Mastodon or LinkedIn, I'm happy to chat with you there as well.